Problem number 4 on our rational functions practice quiz is just to solve this equation. And it is a rational equation because it is composed of rational expressions, 1, 2, 3 rational expressions. And so the first thing I'm going to do is just think about how do I combine all of these rational expressions. I need a common denominator to do that. And it might not be obvious what the common denominator is here, but if I factor the bottom of this quadratic down here, if I factor that, it might illuminate what I need to do to find a common denominator. So there's the factored version of that first expression. I'm just going to add 1 to that and bring down the other, the right-hand side. So I just factored here. That's all I did. I can see now that if I had an x minus 3 and an x plus 3 on the bottom of this and this rational expression, then I would be able to, I would have a common denominator. So let me just do that. I want, instead of just a 1 here, if I really want my denominator to be x minus 3 times x plus 3, I need to multiply the top and the bottom. Really 1 over 1, and I'm just going to multiply x minus 3, x plus 3 divided by x minus 3, x plus 3. Okay, so that's just 1. This whole thing really reduces to 1, but now I've rewritten it in a way that has a common denominator with this first expression. And on the right-hand side, I have an x minus 3 on the bottom. I need an x plus 3. So if I multiply that x minus 3 on the bottom times x plus 3, then I also have to multiply the top by x plus 3. And now I found a common denominator. So according to the properties of equality, right, if I do a mathematical operation to one side of this equation, I have to do the same operation to the other side, and then my equality is maintained. I can still say that the two resulting computations are equal if they were equal before. So if I multiply both sides of this equation by this denominator, I will effectively be able to cancel out all the denominators, and I would be left with 30 plus x minus 3 times x plus 3, and that will equal 5 times x plus 3. Okay, so what allows me to do that is the multiplicative property of equality. In other words, multiply both sides of the equation by something, the equation is still true. I just multiplied both sides of this equation by x minus 3 times x plus 3, and this is the result. So now it's a much simpler equation. I want to write it in standard form. It is a polynomial, and if I multiply this x minus 3 times x plus 3, if I multiply that back out, I get that, and on the right-hand side, 5x plus 15. Okay, so that's really just using the distributive property on the left and the right-hand side. And next, I'm going to subtract these two terms from both sides so that I have all of my terms on the left and 0 on the right. And when I do that, I'm also going to write it in standard form. I got x squared minus 5x, and let's see, 30 minus 9, that's 21. And 21 minus another 15 is a positive 6. And that all equals 0. And I can do that thanks to the properties of equality. Specifically, the subtractive property of equality. Let me write that a little better. Subtractive property of equality. And this should be pretty simple to solve. I can factor this. We all like quadratics that can be factored. There's the factored form of this quadratic. Okay, so factor. And then I can say x minus 3 equals 0 or x minus 2 equals 0. And I can do that because of the 0 product property. And this leaves me with x equals 3 or 2. So those are my solutions right there. Let me just bring this up here like this. So the last thing I want, now I've got a solution. It's great. I've got two values of x that I got when I solved this equation. But remember, when we solve an equation, we're looking for the values of x that cause this equation to be true. And we have to think about the extraneous solutions. There are some values that cause this equation to be undefined. And when we look at the factored form of the equation, it's easy to identify. X equal to 3 or x equal to negative 3 would cause one or more of these expressions to be undefined and thus cause the equation to be undefined. And notice that's a solution that I came up with. I said x equal to 3 came out of this mathematics. And so the reason why that extraneous solution shows up is because when I go from this step to this step, I end up canceling out all of my factors on the denominator, and I eliminate the whole thing that causes this equation to be undefined. That is the denominators. And so this is why I always have to go back and check for extraneous solutions. And when I notice that 3 is an extraneous solution, I'm just going to make a statement about this. I'm going to say x equals 2. That's my solution. X equal to 3 is extraneous because it causes the original equation to be undefined. So I identified the extraneous solution and I explained why it's extraneous too. But this is really my solution right over here.